Algebra 1 Test 16 Study Guide. The number of bacteria increased by 120%. So increased by 120% means 120% more. So we're looking at a before and after situation. And it says overnight, so the before is yesterday, after would be today. And when we do before and after for percents, we're going to put before at 100%, and then the after is going to be based on the increase or decrease. So in this case, increasing by 120%. We started at 100, to increase it by 120 puts me at 220%. There were 40,000 bacteria yesterday. How many are present this morning? So yesterday is before, so 40,000 is the actual number before. How many are present today after? So that's the setup. And if I just set that fraction equal to that fraction, all I got to do is cross multiply to get the equation. So 100x equals, let's see, 22 times 4 is 88, and we got a total of 1, 2, 3, 4, 5 zeros. So 8,800,000. Divide both sides by 100. And what that does is it chops 2 zeros off of that. So we end up with 88,000 bacteria as the correct answer. A popular wrong answer for this is 48,000. That's because instead of seeing the increase by, we think 120% of. But again, it's 120% increase before 100, increase 120, so now after 220. So be careful of that on problem 1. Number 2, Edna and Mabel climbed 35% of the mountains in the whole country. So 35% of. Now this is a part-whole situation. So they climbed 35%. They did not climb 65% for a total number of mountains of 100%. So, you know, anytime they give you the percent that happened, there's always the percent that didn't happen. So 35% happened, 65% didn't happen for a total of 100%. They climbed 175 mountains, so the actual number of mountains they climbed was 175. How many mountains were in the country? So the total number of mountains is what they care about. So this did not climb is not important. Once again, this fraction, 35 over 100, is equal to that fraction, 175 over x. So 35 over 100, clean it up a little bit, equals 175 over x. Cross multiplying 35x is equal to 17,500 for that product. Divide both sides by 35. That was not quite so easy to do in my head. So 17500 divided by 35 comes out to 500. How many mountains were in the country? 500 mountains were in the country. Number 3, graph. It's an inequality. It's a negated inequality. So the first thing I want to do is focus on this negated inequality. Our trichotomy axiom says greater than, less than, and equal to the 3 options. This is saying not less than. So what's left over would be greater than or equal to. So x minus 5 is greater than or equal to negative 7 is equivalent to the original problem, but it's in a regular inequality structure that we prefer. I'm going to get x all by itself, so I've got to move the 5 to the other side, so minus 5 moves over as a plus 5. X is left on the left-hand side, greater than or equal is not affected by such a move. Negative 7 plus 5 is negative 2. Subtraction because the signs are different. Negative because 7 is bigger. And at this point I want to graph this inequality based on this domain set of real numbers. So I want at least 5 dashes. I'll put 6. I'm going to go negative 4, negative 3, negative 2, negative 1, 0, 1. No magic to these numbers. Just make sure this number shows up on your chart there. Real numbers are just regular graphing. So I've got to make the decision of hollow circle or filled in circle. I'm going to go with filled in circle here because it says equals to. And greater than goes to the right, so I'm going to then shade off to the right. And I'm going to make the arrow much bolder on this side than I make it on the other side. So that's that. Number 4, write an inequality. Now it says remember to designate the domain. If you're putting the domain on yourself, you have 2 choices. Choice 1 is reals, choice 2 is integers. Okay, it's real simple. If it's dot, 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 it's integers. If it isn't dot, 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 it's reals. So I mean, that's all there is to designate a domain on these. So know the domain is going to be integers on this one because it's dot, 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 dot. If it had gone like this, now it's reals. All right, so that's the difference in domains. As far as what we're graphing here, I'm starting at 6 and getting smaller. So x is less than or equal to 6. Domain equals integers. I could have also gone x is less than 7. Domain equals integers. Either way I do it, this says to start at 6 and go less. This says to not start at 7, but the first integer below 7 is 6 and then go less. Both of these are correct. I'd probably go with that one personally, but again, I'm not going to count either one of those wrong. When the domain's reals, there's only one answer, but with integers, there's quite often two answers like this because, again, less than 7 means first integer less than 7 is 6 and everything below. Less than or equal to 6 means start at 6 and then everything below. They mean the same thing. Number 5, simplify square root of 108. So if I do a factor tree, 108, probably 9 times 12 would be an easy one. One of our multiplication facts. 12 is 4 times 3. 3 is prime, 3 is prime, 4 is composite, 2 times 2. Make sure that you get down to all prime numbers here. So 3 times 3 times 2 times 2 times 3. If you're not sure that's exactly right, all you got to do is type in your calculator 3 times 3 times 2 times 2 times 3. Type in your end result of your factoring in your calculator, it equals, and see that you get the same number, 108. That just verifies we're on the right track. I'm going to then write a big square root like this, and I want to put this inside. I like numerical order personally, so 2 times 2 times 3 times 3 times 3. So I just transfer that up there. And what I'm looking for is a pair of factors. So a pair of 2's means 1, 2 gets to come out. A pair of 3's means 1, 3 gets to come out. Anything that comes out with anything else is going to multiply by what's already out there. And then 3 doesn't have a pair. This pair of 3's happened, so those are gone. The 3 that's left over has no pair, so it has to stay in. My end result is then to multiply what's left over inside and what's left over outside. So 3 times 2 is 6. Outside, inside all that's left is a 3. 6 times the square root of 3 is equivalent to the square root of 108. That's the simplified form. If you type in your calculator, square root 108 equals, and type in, and you get 10.3923045. You can go out 5,000 decimal places if you want to. That's wrong because it's not the simplified version, it's the approximate version. So be careful. When it says simplify, you see a radical, I'm looking for an answer looking like this. So do this technique here. Number 6, we just learned the elimination technique. On the test, I don't specify a technique. If you like substitution, you can use it. If you like elimination, you can use it. I prefer elimination, so I'm going to go that route. And if I'm doing elimination, I'm looking at my variables. I like opposite signs already there. So I'm going to go with my y's. I'm going to choose to eliminate y. I've already got the correct order of everything. I've got x, y number, x, y number order. My goal is to make those two highlighted things the same but opposite. The opposite signs are there. If I double this bottom equation, positive 2y is the opposite of negative 2y. So that'll do the trick. So 3x minus 2y equals negative 18 is staying the same. 2 times 5x is 10x. 2 times 1y is positive 2y. 2 times negative 17 is negative 34. Once I get the desired result, which is opposite signs and opposite terms, on the variable I want to get rid of, I simply add the equations. 3x plus 10x makes 13x. The signs are the same, so I add. Negative, positive 2y cancel. Negative 18 and 34, again, the same sign, so I add. I get negative 52. 13x equals negative 52 divided by 13. That gets me x equals negative 4. Once I know what x equals, I go back to any equation I want to. I like this one right here. 5x plus y equals negative 17. 5x plus y equals negative 17. Instead of x, I'm going to write negative 4 because that's what x equals. Negative 20 plus y equals negative 17. Move the 20 over, becomes plus 20. That gets me y is equal to positive 3. x is negative 4, y is positive 3. Always write your answer as an ordered pair. Number 7, same deal. Only difference here, notice the order of things in the top equation. It's not the right order. So the first thing I would do with this problem, if I want to use elimination, is rearrange. So 2x plus y equals 10. X plus 2y is equal to 11. So now they're both in x, y equals number order. Again, I got to get rid of a variable x or y. It doesn't matter which one I choose. I'm going to go with y again. This is positive y, that's positive 2y. They're the same sign. So what I'm going to do is I'm going to multiply by a negative 2 on the top. End result will be negative 2y to go with the positive 2y. The consequence is that this becomes negative 4x, that becomes negative 20. So all the signs change, but I get what I'm looking for. So if I do my multiplication here, negative 2 times 2x is negative 4x. Negative 2 times y is negative 2y. And negative 2 times 10. Negative 2 times 10 is negative 20. So, if I am to add the two equations together now, the y's are opposites like they should be. I'm going to add or subtract based on sign. So what I have here is 1x minus 4x is negative 3x. 2y minus 2y is 0. 11 minus 20, again opposite sign, so I subtract, I get negative 9. Negative 3x equals negative 9, divide by negative 3, and that leaves me with x is equal to positive 3. Two negatives make the positive. Once I know what x equals, I go back to one of the equations. I'm going to go right here. It says x, which is 3, plus 2y equals 11. We move the 3 over, that gets me 2y is equal to 8. Divide by 2, we get y is equal to 4. Again, x first, y second of ordered pair. X is 3, y is 4. Make sure we write our answer as ordered pairs in those problems. Number 8, graph y equals negative 3x plus 4 on the following graph. Okay, y equals is already there, so we're ready to go. We always want to start with 0 common number because that's easy. All 0 does is it makes this term here go to 0, so I'm left with y equals 4. Easiest thing in the world to do. Okay, once you get that number, we're dealing with whole numbers here. Negative 3 are integers. So if you got whole numbers or integers, just going up by one at a time is easy enough. X equals 1. I'm just changing this x to a 1. So y is going to be negative 3 times 1 plus 4. Negative 3 plus 4 equals 1. For x equals 2, again, changing this to 2, I'm going to get y equals negative 3 times 2 plus 4. That's just negative 6 plus 4, which is negative 2. And just like that, I got 3 points. 1, 2, 3, 4 up the y-axis, so 0, 4. The 0 common number is always on the y-axis. Be careful that 1, 1 is right here, and then 2, negative 2 is right there. 3 points in a straight line, and then connect the dots with a nice straight line. Like so. You make sure there's arrows on the ends of your lines, but again, it should be pretty much like that on the test. Number 9, g of x equals this expression. Find g of negative 4. Be careful. It says g of negative 4, that's a negative number, x is being squared, which means that the negative and the number are being squared. So x squared is negative 4, the quantity squared. Minus 3x is 3 times negative 4. X minus 2 is going to be negative 4 minus 2. I got it, maybe did a little overkill there with my parentheses and brackets, but I really want you to see that. So negative 4 squared. Not just 4, but negative and 4 both being squared there. So negative 4 times negative 4 is positive 16. Minus 3 times minus 4 is positive 12. Subtraction changes to addition. It will not change to multiplication. In the second parentheses, negative 4 minus 2, that's just subtraction, but they're the same sign, so I'm going to add. So I'm going to get negative 6. 16 plus 12 is equal to 28. And 28 times negative 6 is 168. It'll be negative because the signs are different. Okay, No shortcuts on that for the most part, just a matter of evaluating it correctly. So order of operations, again, pay attention to detail on the substitution. Negative and 4 both being substituted, and they're being affected by whatever is up there. So make sure that you do it properly there. Number 10, multiply. 3x plus 1 times 2x plus 4. Binomial multiplication, probably the easiest way to do it is FOIL. So 3x times 2x is the first times the first. Outside times outside. 3x times 4 is going to be plus 12x. Inside times inside, 1 times 2x is going to be positive 2x. Last times last, 1 times 4 is equal to 4. The end result is that 3x multiplies by 2x and 4, 1 multiplies by 2x and 4. That's what ends up happening. And typically when you multiply binomials that are linear like this, you're going to get like terms. Expect that, so be ready for that. 6x squared is fine, there's no other x squared terms. 12x and 2x makes a total of 14x, adding because the signs are the same, and then plus 4. Can't do anything else to it. X squared, x, and 4 are not like terms, so cannot add or subtract them any further. Add, write the answer with exponents positive, and this is a fraction problem in disguise. This would be a on top, x to the first, y to the second on the bottom. This is going to be plus by is on top and x to the first is on the bottom. And what you should see, hopefully, is that the denominators are exactly the same except this has a y squared, that doesn't. So I need a y squared on the bottom, so I need a y squared on top to account for it. And just like that, the second fraction now is xy squared, just like the first fraction. Common denominator exists, so xy squared is the least common denominator on the bottom. A plus by cubed is on top, and that would be the answer. Keep in mind when you multiply y's, you add the powers. 1 plus 2 is 3. Number 12, simplification. The first step of simplification of exponents, notice there's no pluses in this problem or minuses, just numbers raised to powers being multiplied and divided. So first thing I want to focus on is each of these parentheses. I want the parentheses to go away. Everything else I'm just going to leave alone. So kp, k to the negative third, I'm going to rewrite k, p, k to the negative third. I put some first powers on there. It's advisable at this point in time until you get really good at these. Make sure the first powers show up. And then k and p on the bottom, I'm going to leave them alone. And then as far as what's in the parentheses, p to the negative second to the third gets me a p. Negative 2 times 3 is negative 6. We multiply inside times outside power. I got a k to the negative 4 to the first, so that just negative 4 times 1 is negative 4. And then p, negative 3 times 2 is negative 6. So that's priority 1. What's in red is what changed, what's in blue is what stayed the same. I didn't modify anything in blue, just the red stuff. And by doing that rule, by multiplying inside times outside power, I made the parentheses go away. So at this point I just got a bunch of terms on top and bottom. Next thing I care about is negative powers. Everything negative power needs to move. At this point also, if 0 powers were there, I'd throw them out. Times 1 doesn't do anything. Everything circled in green needs to move. Everything not doesn't. So k to the first, p to the first is staying on top. I'm moving a k to the fourth and p to the sixth up. And then k to the first, p to the first on the bottom, and I'm moving a k to the third and p to the sixth down. So these two moved up, became positive powers. These two moved down, became positive powers. Next step, I got too many k's and too many p's on top and the same deal on the bottom. So on top, I got k, 1 plus 4 is 5. I've got p, 1 plus 6 is 7. On the bottom, I've got too many k's, I've got too many p's. For k, 1 plus 3 is 4. For p, 1 plus 6 is 7. Final step is division. And one or two things will happen with division. Okay? You're going to have the same letter on top and bottom. When that happens, you either have different powers or the same power. If you have the same power, they just cancel. So just throw out p. If everything cancels, the answer is 1. As you can see, the k's don't cancel. All right? You have to make a decision where k belongs. Bigger on top, so k belongs on top, so not a fraction. 5 minus 4 equals 1. K to the first power is the right answer. I would accept also as k. First power is understood. 13, simplify by adding like terms. Okay, so we have to first of all fix each of these objects, then add them together if possible. So it's kind of like number 11 was, except on number 11 we had to actually add them together by getting a common denominator. Here, only add them if they're capable of being added. So this needs to be modified. 4 and x belong on the top, y squared belongs on the bottom, negative power. Second term is plus. 3 is fine where it's at, x belongs on the top, and y squared belongs on the bottom. The third term, minus 7 on top, is fine the way it is. Y squared belongs on top, x to the first belongs on the bottom. Looking at these, x to the first on top, y squared on bottom. These two guys are like terms. This has x to the first and y squared also, but in the wrong spots, so this is not a like term. So altogether, I can add these two things together, but I can't add that. So 4 plus 3 makes 7. What made them the same was x on top, y squared on the bottom. Minus 7y squared over x. Cannot go any further than that. Again, adding like terms, I'm looking for an answer like that. If it says add, write the answer with all exponents positive, they want you to actually get a common denominator. If you see add like terms, they simply want you to add what you can add. Don't worry about getting a common denominator in that scenario. 14, expand using distributive properties. So first thing, I've got my parentheses, so I'm going to keep my parentheses. I want to fix each of these objects in the problem. So that x cubed belongs in the bottom, y squared stays in the bottom, nothing's on top, so I put a 1 up there. X to the fourth y cubed is behaving itself, it gets to stay x to the fourth y cubed. I'm going to put it over 1 just to create a fractional structure to it so I can better see what I'm supposed to multiply. And then this, also behaving itself, everything's positive power, so negative 4 over x cubed y squared. Don't be falling into the trap, you see a minus sign, you think you have to move something. It's 4 to the first power. First power is a positive power, so it's right where it belongs. Oops. How did that happen? So, once you get everything simplified to that extent where their powers are all positive, now it's just a distributive property. So I'm going to multiply this times this, and I'm going to multiply this times this. And when I multiply, it's top times top, bottom times bottom. So, on the orange multiplication, 1 times x to the fourth y cubed on top makes x to the fourth y cubed. X cubed y squared on the bottom times 1 makes x cubed y squared on the bottom. Don't worry about the fact there's x's and y's. We'll worry about that in a minute. For the purple multiplication, positive times negative makes a negative. On top, 1 times 4 is 4. On the bottom, x times x I add powers. Y times y I add powers. Looking at the two terms, the purple term is perfectly fine. We have 1x, we have 1y, the powers are positive, everything's good. The orange term has too many x's, too many y's. So the last thing to do is to simplify that, same way we did on the last problem, on number 12. X is bigger on top, that's where it belongs, 4 minus 3 is 1. Y is bigger on top, that's where it belongs, 3 minus 2 is 1. Over 1, which I don't have to write. Okay, if I end up with a non-fraction, I'm fine just writing it as a non-fraction. The second term, I can't make that any prettier. And for distributive property problems, again, don't worry about getting a common denominator. The only one you have to really add together with common denominators is number 11. Finally, number 15, find the perimeter of this figure. Perimeter is the sum of all the sides. I have to find out how long each side is. A couple of things are missing right here. I don't know how long that side is. It means the fact this rectangle's here. 5 up and 5 down makes a diameter of 10, which means this is 10 over here. I do not know how long this is, the semicircle. Alright? But it's half a circle, and the formula for half a circle is radius times pi. 5 is not part of the perimeter. I'm not walking that if I'm going around the figure. I'm going around here. And again, that 5 led to that 5 pi. Same argument goes for this. If I go from here around to here, 5 times pi, I'm not actually walking that, but that leads me to that. Okay, so if I'm walking around the figure, if I start here, I'm going to go up 10, around 5 pi, 9 more than 5 pi more than 19 more. I simply have to add up all those numbers. I do recommend getting decimals for the pi's, so 5 pi is 15.70. This 5 pi is also 15.70. So, if I add up all the pieces, I've got 10 plus 15.70 plus 9 plus 15.70 plus 19. Right. So just adding them all up, 15.70 makes 31.40. 10 plus 9 is 19 plus 19 is 38. Add those up, I get 69.40, 69.4 centimeters. Okay, so expect a similar looking figure. I'll have different dimensions, of course, but same type of figure. Half circles will be happening. You probably have to know a diameter in order to find a missing side like that, so be ready for those types of issues.